Hello, welcome back. Again, this is some additional help in case you need some help on your Excel skills. These ones are for specifically P7 through P11. So I'm probably going to do more than one out of several of these just because they're getting a little bit more difficult. You can always use these as a reference to come back to if you are having difficulties on any of these Excel skills. So let's go ahead and get started. The first one we're going to look at is P7. They want to know, are these triangles similar or not? Well, let's first take a look at each of the triangles. 96. Is there a 96 anywhere on this triangle? So I see this is 96. Is there anyone over here? I don't see one. Well, is there a 50? I see a 52. There is a 52 over here. So we got to figure out what this third angle is. As a reminder, all three angles of a triangle have to add up to 180 degrees. So 52 plus 96 plus x has to equal 180. So I'm going to take 52 plus 96, and I'm going to get 148 plus x equals 180. Subtract 148 from both sides. So 180 minus 148 is 32, so x equals 32. Now, if I have 32 over here, am I going to be able to get a 96 over here? We have to think about that. If we're not sure, we can always figure out what the three sides angles have to be in this other triangle. So it's the same thing. We're going to do 50, that different color. So 52 plus 86 plus, let's call this y. Y equals 180. So 52 plus 86 is 138 plus y equals 180 minus 138 on both sides. So y is going to be 136, 44. Now, are those angles the same in the both triangles? The answer is no. So our triangles are actually not similar. The only reason I had yes popped up is because if you say yes, then you have to actually write how the triangles are similar. And we'll get into that a little bit later on. Or we've covered it earlier. If you're not sure, you go back to one of the earlier P-Squills in our similarity video. Here's another one. Let's see if these are similar. So now I'm not given angles, I'm given sides. So again, I have to look at ratios. So if I'm not sure, I'm going to look for the, let's see, 32 here is, looks like the smallest side out of the three. So the smallest out of the three would be 40. So I'm going to do 32 over 40, and I'm going to pair that to the middle sides. So the middle sides are 48 and 60. Is that the same as 48 over 60? And the last one I have to look at is 56 and 70. Is that the same as 56 over 70? Well, let's figure that out. 32 divided by 40 is going to give me 0.8. So that's 0.8. 48 divided by 60 is also 0.8. And 56 divided by 70 is also 0.8. So since those are all the same ratio, yes, these two are indeed similar, which means I now have to write a statement. So I can write the first one in any order. So I'm going to do RPQ. So RPQ. Remember, the order is important. So I'm doing the red to the green to the blue. So from red to green is EGF. Oops, I don't know why that keeps popping up. Stop it. EGF. So from red to green to blue is EGF. And there's my similarity statement. Alright, now we're going to jump to P8. P8 gets a little bit harder because now we have to go back to our old translation rules as well. So we can perform a transformation on triangle FGH, which is our pre-image, to triangle F prime, H prime, G prime, which is our image. And then we're going to perform a dilation on it. So these two triangles are similar. They want us to find the translation rule and find the scale factor. So we've got to find two things. So the first thing I'm going to do is find the translation rule. I like to focus on the point that's already at the origin. So at this point it is the H to the h prime, I gotta figure out how I'm gonna move that h to get it all the way up to the h prime. So I'm gonna move it over this way, which is to the right, and I gotta figure out how many units I'm gonna move that over. So I'm gonna move that to the right 8 units, so that's x plus 8, and then I gotta figure out how many units I'm gonna move that up. I don't know if you can see that. There we go. So that is y plus 7. So remember, up is plus, down is negative, right is plus, left is negative. So now I've got my triangle to be up here. So I'm going to put my triangle just like it would be if it was on top of itself. So I figured out how to move it. So that's my first important part. Now I got to place the triangle as if it was just there. So if I look here, so h, I go down 2 over 1, that's my new f. So that would be my f. And then this would be down 2 over 2. So here would be down 2 over 2. So this would be my g. So that's like my g. So that's my triangle. So I have to figure out what is the distance from here to here. Now I could go back and I could do the midpoint, or do the distance formula, but that gets complicated and messy. I do have a really nice one where I could just count. I have this line right here, because remember this line right here is also similar to this line right here, so I'm just going to use that. So this line is 1, 2, 3 units, and this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. So if I look at what is the scale factor, 3 over 12, actually I'm going to do that the other way. If I do 12 is the big one over 3 is the small one, that means that the new one is 4 times bigger than the original. So my scale factor is actually 4. Let's try P9. Again, very similar. The only difference is I have circles instead of triangles. So I have less to work with a circle. In a circle, all I have is a center, and I have this thing for a radius. So again, we are going to find the translation rule and the scale factor. What I always do with the translation rule is, since I only have one point to work with, which is the center, I figure out where am I going to move this I to get to my new I. So I have to move it, again, to the right 3. So that's going to be x plus 3. And then I have to figure out how many am I going to move it up. So I've got 7 here plus another 4, so that's y plus, plus 11. So I moved it right 3 and up 11. Now, it's a little bit different when I have circles, because when I have circles, the only other thing I've got to go off of is a radius. So if I look at the radius of my original circle back here, the radius, I can count that, r equals 3. If I look at the radius of my other circle, let's see if I can do that I'll do that in purple. I can count that one. Oop, too far. R is going to be 1, 2, 3, 4, 5, 6. So R is 6. So if I look at 6 versus 3, 6 over 3 is 2, which means my scale factor is 2. My new circle is 2 times bigger than my smaller circle. Alright. This one you'll watch after you watch the 6 point. You'll do after you what? This one you will do after you watch the 6.3 video. Sorry about that. Which is going to be the triangle splitter theorem. Very important. It says that FG, where's FG? FG right here is parallel to HI. Very important. That means that this side is proportional to this side, and this side is proportional to this side. So they want us to find GH. I don't know what GH is, so as always, I'm going to give it a letter. Let's call it X. I can set up a proportionality, means x over 28, so the small one to the top one, is going to equal 6 over 12. Now you can probably see where this is going, but we're going to do the cross multiplication because you never know. We're going to cross multiply this guy. So 12x equals whatever 28 times 6 is. So 28 times 6 on my calculator is 168. to get x by itself, I gotta divide by 12. So 168 divided by 12 is gonna be 14. So x equals 14. And since we let x equal gh, so x equals gh, gh is 14. One more, just to be on the safe side. So again, I can do the same thing when I am looking at sides. They want us to find ST. Now, I'm not necessarily sure how to find ST yet, but I can find some information. So if I know that this little side is 11 and the whole thing is 33, I can figure out what PQ is. PQ is going to be 33 minus 11, which is going to give me 22. Now that's going to help me out with my ratio, because I don't know what the whole length is for T to R, but what I want to find is ST. So I just want this little thing up here, from here to here. And again, since I want that, I'm going to call that X. So what I'm going to do is I'm going to set up another proportion. So I'm going to do 11 over 22 equals X over 16. You guys can probably already see what X is, but we'll just multiply it out. So 22X equals 1 times 16, which is 176. Divide both sides by 22. We're going to get X is 8. Now let's see, does that answer make sense? Well, 11 is half of 22, so 8 should be half of 16. Yeah, that looks good. So ST is going to be 8. Alright, 11. Now we're going to get to areas of similar figures. Now, areas is a little bit different than perimeters. Back when we did, what was it, P6, when we did perimeters of similar figures. With perimeters, all we did was add the sides together, and that was enough to get us the perimeter. But when we have area, we're multiplying, usually length times width. Now, since we are multiplying things, that means we're going to have to multiply some stuff together. So, I like to call this, let's call this one A, we'll call this one B. Since I'm multiplying two things together instead of just adding a bunch of stuff, it's going to be like A squared over B squared equals A1 over A2. That's the formula that we're going to use for these. So if I fill those in, I'm going to get 1 squared over 7 squared equals A1, I don't know what that is, over A2 is 343. So again, we're going to multiply this out. So let me get this out of the way. There we go. We'll put this over on the side so that we know what it is. A squared over B squared equals A1 over A2. There we go. Alright. 1 squared is 1 times 1 is 1. 7 squared, 7 times 7 is 49 equals A1 over 343. Again, we are going to cross multiply them across. So we're going to get 49A1 equals 343. If I divide both sides by 49, so 343 divided by 49 is going to give me 7. So the area A1 is 7. And that's how I'm going to do that. Alright, one more, just so that we're all on the same side. Again, A squared over B squared equals A1 over A2. So if we have, I'll call this A, we'll call this B, 3 squared over 8 squared is going to equal 9 over A2, because I don't know what A2 is this time. So 3 squared is going to be 9 over 8 squared is 64, is going to be 9 over A2. I bet you guys can already figure out what A2 is going to be, so let's just go ahead and multiply them out. 9 times A2 is going to be 9 times 64, which is 576. Divide both sides by 9, and we're going to get A2 is going to be 64. Alright, so I just wanted to do this to show you that no matter what the shape is, the formula still applies. Alright, I hope this helps, and again, if you have any questions, please feel free to come to see me for more assistance.